Chapter 10, talking about circles. So a little bit more of in lesson 2. We're going to talk about arc measures. So the essential question today, how do you find the measure of an arc? So a central angle is an angle that's at the center of a circle. So it's pretty basic. We'll just say an angle at the center. We'll try to spice it up a little bit. An angle with the vertex at the center. So this would be an example of a central angle. And when you create a central angle, you actually create not one, but two arcs. The minor arc, so this would be considered it's the one less than 180 degrees. And then you've also got the major arc, which would be greater than 180 degrees. Okay, so minor arc, major arc, and then the arc is just this part of the circle on the outside. All right, a semicircle is an arc with 180 degrees. So if I have something like this here, this has exactly 180 degrees. It's got a straight line, it's a diameter. I think you guys all know what a semicircle is. Congruent circles, congruent circles would be, circles with a number of things, but we'll say with equal radii. So if the radius is the same, then the diameter is the same, then the circumference is the same, then the area is the same, and that's all good. And then congruent arcs. Congruent arcs are arcs with the same degree. Okay. All right, well, the big thing today, and we'll see this on Geometry Sketchpad, if you open up that, is this. So you have a central angle. Say the central angle is 45 degrees. Well, and you kind of measure this. Well, this arc measure is also 45 degrees. You can think of it, simply because a circle is going to have 360 degrees, and so if this takes up 45 of the take up 45 of the 360 degrees. So that's the central angle theorem, that the arc degree is exactly the same as the central angle degree. And that's really all there is to it. Examples, for instance, this one. Find the measure of each arc where AB is a diameter. We know it's a diameter because it's a straight line that goes through the dot there at the center. Find arc DB. Well, here's just one kind of quick thing. If we have two letters, we're going to assume that it's the minor arc. Okay, with DB, technically I suppose you can say you got this one and this is also a DB. But when we have two letters, we're going to assume that it is the minor arc, and so, if the central angle is 135, then that arc is going to be the same, 135 degrees. If we have three letters, we're going to assume that it's the major arc. DAB would start at D, it would go through A, and then all the way over here to B. And again, sometimes we just have to look a little bit into it. If we know that there's 360 degrees total, for this one I could just take out 135 degrees, and we have 225 degrees would give us the rest. So DAB, 225, and then arc ADB. Well, we know this is 135, but we don't have any values for this, which could be a problem, except that we know this goes through the center. It's a diameter, and so we know that it's 180 degrees. All right, last thing here for lesson 2. Tell whether or not arcs CD and EF are congruent, and then explain why or why not. Well, here is pretty easy. You got the central angle is 45, and this is also 45, so that means this has to be 45 and this has to be 45. So yes, this one, they are congruent. Let's see here, if this central angle is 110 degrees, it's a little hard to see there, sorry about that, but if this central angle is 110 degrees, are both of these arcs the same thing? Well, the central angle being 110 degrees means that this would have to be 110 degrees. And then if that whole inner circle was gone and we were just looking at the other one, we would also assume that this was 110 degrees. And so we're going to say yes, these are both 110 degrees. So again, remember, it's not the length of the arc, that would actually be different, but the degree is the same. All right, and then the last one, here we've got CD and EF. Here's CD, here's EF. We don't have any numbers at all, so how can we tell? Well, we still remember things like the vertical angle theorem, meaning that we've got these two lines, these are vertical angles, and they must be congruent, and since they're the same, this arc has to be the same as this arc. All right. So there you go. That takes us through lesson 2, probably the easiest lesson of the entire book.